with the actual review. Okay, so I have about 21 problems to review. I'm gonna try my best to be as detail oriented as possible, but obviously there could be something that slips under the cracks. Um, just let me know. This isn't all encompassing. This isn't gonna be a photocopy of the exam, but it is gonna be pretty as close as I can legally get, I guess. Okay. All right, let's begin. Okay. So first we have this integral set up here. This is not a substitution. We definitely have to do integration by parts. We'll let u be x since that will decrease. Du is dx. And we'll let dv be e to negative x dx. Excuse me, that means v is negative e to negative x. Okay, then from here we set this up as negative x e to the negative x, multiplying these two, and then doing the subtraction of this integral. So positive e to the negative x dx, which, you guessed it, will be negative e to negative x plus c. So don't forget u substitution. This was an instance of the u picking a u that would make the thing smaller. This is a good synopsis. Also, I don't think I said it. I'm gonna say it again. The added formulas I will provide. This is just a wink and nod at the trig substitution methods. This is just some of the derivatives and integrations that I think I already included in your formula sheets. And then just some classic trig ones. I'm gonna include this, but I'm not gonna include how to do it. And yes, okay, pretty much it. Right over here we have integral x times sine of 2x dx. For here, this is also a situation where we're gonna go ahead and use x. So I'm sorry, u is equal to x, du is dx, and then we have dv is sine of 2x dx. So v must be 1 over 2 cosine, negative 1 over 2 cosine of 2x. Yes. Okay. All right. We're going to go ahead and write that out to be negative 1 over 2x cosine of 2x. And then minus this setup, which makes that positive, 1 over 2 integral of cosine of 2x dx. That just comes out to 1 over 4 sine of 2x, and then plus c. Okay. I'm just checking my answer key, just making sure I have everything mentioned here. You're very good. Okay, cool. Next, we have another situation with using the u substitution, but this one we have it to where just doing the whole thing makes the problem more legible. So I'm going to do u is equal to cosine of ln of x, and du is then the derivative, so sine of ln of x, the derivative what's inside of it, so times 1 over x, and then dx. dv is just going to be dx, and then v is just going to be x. So then we have x times cosine of ln of x. And then we have this combined, so minus, which I'm going to take that minus, we get plus integral of sine of ln of x. That will cancel out, and then dx. So it seems like we're not going to get rid of this anytime soon, but we know that these cosine ideas tend to repeat. So we will probably happen is we'll make this appear again, then solve for this the old-fashioned way. So let's go ahead and do that again. So we use a different color. I'm using an obvious different color because I was about to grab like a dark blue, which is kind of not the point. So u is sine ln of x, and then hold on, my headphones acting up. Okay, there you go. And then du is cosine of ln of x times 1 over x times dx. dv is just dx, and v is just x. So we're going to replace this whole thing with that. We have from before the x cosine of ln of x plus these guys multiplying, so x sine ln of x, and then minus these, which is cosine of ln of x, and then the 1 over x and the x cancel out, and you're doing dx. So don't forget what this was all initially equal to, this. So we can add it to both sides, and then just divide by 2 to get the answer, and then we need to go ahead and include a constant. So therefore, your answer should be x times cosine ln of x plus x times sine ln of x, all divided by 2, and then plus c. Okay, let's move on. Okay, over here, we have an issue where we have ln of x and x squared. Now, technically for this, we know that if I keep taking the derivative of this, it will disappear. Or will it disappear? Not necessarily, because I know derivative of this is 1 over x. The derivative of that then is going to be 1 over 2. And then same thing over here for 1 over x2. That's just going to keep repeating. So in this case, it's almost better to just treat one of them, take a shot in the dark, and see if the problem becomes more legible in that respect. So in this case, let's see. You can write it as here. So I'm gonna start to do it just a little bit. So you do u is x squared, dv is ln of x dx. And then you have u is ln of x, and dv is x squared dx. Oh, I'm sorry, not x squared, negative 2. Or, yeah, I'm going to rewrite it like that. I did that mentally, but I didn't do that out loud. I apologize. ln of x times x to the power of negative 2 dx. Okay. So right here is kind of where we stop, actually, because remember the other step I said with integration by parts. You want to do a dv that isn't complicated and straightforward. In these cases, these dv's are very different in terms of difficulty. This one is more complicated. This one is just a power rule. So we're better off just doing a power rule application. So that means du is simply 1 over x dx. And then I'm sorry, not dv, v is the integral of this. So it's going to be negative x to the power of negative 1 dx. I'm sorry, not dx. I'm doing the derivative again. Yeah, plus 1 divided. Okay, cool. Just making sure. All right. So from here, we can extend this to be the multiplication of those two. So negative ln of x over x. And then minus, that negative will sneak in, plus the integral of actually 1 over x squared dx, because these two will multiply. And then we know this guy, that's going to be minus 1 over, sorry, I was going to do ux, and then plus c. Don't forget, I kind of glossed over right now, but don't forget the power rule. Is that on your formula sheet? I don't think I put it on your formula sheet. Let me just quickly check. If it's on your formula sheet, I'll leave it there. If it's not on your formula sheet, then I will just mention it right now on the off chance. It it is in your formula sheet. So I'm referring to one of the formulas on the right side of that integrals that says the integral of xn dx is equal to xn plus 1 over n plus 1. In this case, we know we can rewrite that as, let me do it in a different color, write that as x negative 2. So n is negative 2, so plus 1 be negative 1 over negative 1. And then the negative just escapes, and we can rewrite that as the bottom because it's a negative exponent. Okay. All right, let's do this one. Now, this one is our sign tricks. So those are going to be a bit trickier. But remember, I kind of just condensed it like here, odd exponent of the sine, odd exponent of the cosine. If we have the odd sign, then we can factor out one of them to be sine to the power of 4 of x whole, not plus, times sine of x dx. We're going to turn these into cosine. So when we do u substitution, its derivative will appear. Technically, we can rewrite this as sine squared of x squared sine of x dx. And then we rewrite this as wait, I don't know why I did the parentheses. Integral of 1 minus cosine squared of x squared, and then plus, or no, plus times sine of x dx. In this case, a u substitution would serve me well here, where we let u be cosine of x and du be negative sine of x dx. There's no negative here, so I'm just going to take it out. Negative du sine of x dx. So we can rewrite this as 1 minus u squared squared, and then this will disappear into du, and then don't forget about the negative that goes in front. So then distributing this, we'll get u to the power of 4 times, times minus 2u squared plus 1 du. All of this is u to the power of 5 over 5 minus 2u to the power of 3 over 3 plus u. Force a habit to do definite integral notation. I'm going to go and do plus c here, and then we're just going to go ahead and plug in back here. So I have negative parentheses, cosine to the 5th of x over 5 minus 2 cosine to the 3rd of x over 3, and then plus cosine of x, and then close that and plus c. Okay, that's basically my answer. The only thing I didn't do was distribute that negative, but it's pretty straightforward. Okay, all right. Here, here we have an odd cosine. So we need to turn this into, wait, hold on, let me see. So sine 4 of x. I kind of could just already do this anyway. I don't really need to turn this into anything. Um, because you can just do u is equal to sine of x, and du is equal to cosine of x dx. Yeah. Okay, well then there you go. You don't have to worry too much about this one, because at the end of the day it says odd exponents cosine factor out a cosine and convert the remaining cosines. Oh, that's why I even messed up. I factor the remaining cosines into sines. Well, the sine's already there. So you can literally just do u to the power of 4 du. That's just u to the power of 5 over 5 plus c. And then plug in back u. Sine to the power of 5 of x over 5 plus c. All right. Last one. Here, I'm just double checking my answers. Okay. Here, now we have an issue where we do have to take out the remaining cosines. So sine squared of x, cosine squared of x, and then cosine of x. Turn that into dx. Sine squared of x, 1 minus sine squared of x, cosine of x dx. Using the same thing, u is sine of x, du is cosine of x dx. So that means you have the integral of u squared, and then times 1 minus u squared du. Distribute the u squared to be u squared minus u to the power of 4 du. U to the power of 3 over 3 minus u to the power of 5 over 5 plus c. And then the last step is to plug in back u. So sine 3 of x over 3 minus sine 5 of x over 5 plus c. Okay. All right. Hopefully that's been up to speed. I think that's the last. No, we have one more where we have both of them are odd, which means you can do whichever technically, but we should see that because we have a singular cosine already handily out, we could just replace it. So you have the integral of u to the power of 5 du, u over 6, or u to the power of 6 over 6 plus c. Then you plug it in sine of 6 of x over 6 plus c. All right, now we have those unique substitution terms. Okay, I just want to see something. Okay, so for here, we wrote all of these when you see them, what you replace x with. So for here, I see an x squared minus 9. So that leaves me to do the secant trick, where x is equal to, well, it says 9. So if a squared is 9, then that's 3 secant of theta. That means x squared must be 9 secant squared of theta, and dx is 3, and then secant of theta, tangent of theta, d theta. All right, let's plug all that in. We have on the top 3 times secant of theta, tangent of theta, d theta, over x squared, which is 9 secant squared of theta, and then the square root of 9 secant of theta minus 9. Okay. Well, from here, oh, yeah, and the d theta is here. Okay, so from here, we can cancel out one of the secants already, and that just goes to 1 over 3. So 1 over 3 tangent theta over secant of theta. And then this, the square root of 9 can escape. Secant squared of theta minus 1. That's going to become, this is all just going to become tangent. So tangent, oh, we have d theta over secant of theta, tangent of theta. That's canceling out. And because you have 1 over secant, you could just write that as cosine of theta. And then cosine of theta is sine of theta d, or not d theta. I don't know, I was going to do d theta. But then you have to plug in back theta. So that's where the reference angle comes in. This tells me that secant, which is hypotenuse, over adjacent, over adjacent, which is 3, is like this. And then sine is opposite over hypotenuse, so we just do Pythagorean to get x squared minus 9. So the full answer is 1 over 9 times the square root of x squared minus 9 over x. Oh, plus c. Excuse me. All right, we're just going to double check. Yes, that's correct. A lot of this, guys, is going to be puzzles. How are you doing the puzzles? Are you making sure you're remembering all the tricks, factoring out, things like that? We are going fast. And it's one of those things where it's kind of not up for a debate to go fast because these are heavier problems. So a lot of things are implied. Okay. Obviously, it doesn't mean I'm gonna like try to make your test chunky like that, but it is the nature of the beast. All right, so let's go over here. We have 25 minus the x squared. So our trick. What the? Um, I'm missing pages of this review. I guess give me a second. Let me did I staple into something else? Here, let me still just do this anyway, since we're not roll. Okay. So we're using this trick where it says here, I'm gonna do a different color because we're setting x to be it says a, so 5 sine of theta. X squared then is 25 sine squared of theta. And then dx is 5 cosine of theta d theta. So we're going to plug all those in. We got the x squared on the top, so 25 sine squared of theta. And then we have dx, which I'm just going to write already multiplying, cosine theta d theta, and then on the bottom, we have the square root of 25 minus 25 sine squared of theta. I'm going to let that 25 factor out to be square root of 25, which is 5, which will make the top of this 25. Sine squared of theta cosine theta divided by square root of 1 minus sine squared of theta. And that's just, all of this is going to become cosine of theta, which then makes this problem the integral of sine squared of theta d theta. And then here, did I write them here? Oh, I didn't. Okay, I'm probably gonna also give you the power rules. For this one, 25 is equal to, I believe it's cosine of 2 theta. But I do generally forget. I might as well just not stumble and look for it. 1 minus over 2 d theta. Okay, well, in that case, you factor out the 1/2, but then you basically have the answer at this point. You'll have 25 over 2 parentheses theta, and then minus sine of 2 theta over 2. And then from using sine of 2 theta, you have, what is it? Hold on, I just want to do one, trying to remember. So double angle formula. I believe it is 2 sine of theta cosine of theta over 2. Let me just double check that because I know with the solutions I did that kind of all out. So everything. Yes. Okay, cool. All right, that cancels out. And you're left with one final expression, 25 over 2 theta minus sine of theta cosine of theta. So we have sine of theta, and we have theta technically, but we don't have cosine of theta, so we have to do that reference triangle. There's no way around it. So it's opposite over hypotenuse. This is going to be 25 minus x squared, square rooted. And we have the final answer now. So it's 25 over 2 times sine inverse of x over 5 minus x over 5 times the square root of 25 minus x squared over 5. You can distribute, oh, and then plus c. You can distribute if you want, but really, if you just wrote the answer like that, I would give you full credit. I don't see why not. The only time I remember being like a stickler about like all the different transformations is if you're doing your homework and they give you some kind of formatting issue or formatting nonsense. Okay. All right. This one is it's a secant one. So we're doing x is equal to 2 secant of theta. X squared then is 4 secant squared of theta, and then dx is 2. Did I already do this one? Let's see. 2 secant of theta tangent of theta d theta. So we have 2 secant of theta tangent of theta d theta over square root of 4 secant square root theta, or it's not square root, square theta minus 4. Let the 4 cancel out, or come out. It'll be square root of 4, which is 2, and that will cancel out. Secant of theta tangent of theta over square root of secant squared of theta minus 1. That's going to be tangent, so that will cancel out. And the integral of secant is ln of secant of theta plus tangent of theta plus c. The last thing we need to do, though, is figure out, we don't need to figure out secant, but we need to figure out tangent. Secant is adjacent over hypotenuse, so that means this is 4 minus x squared. So tangent is opposite over adjacent. So we'll have the final formula, or the final answer of x over 2 plus the square root of 4 minus x squared over x plus c. Right. Let me double check. Um, and hold on. I think, did I make a mistake? Let me see. Or maybe I made a mistake here. Secant is x over 2. Secant is x over 2, which stands for. Oh, I did do it. I did cosine. So I need to flip this a little. So I need to flip this. Okay. So secant is x over 2. So that's going to be hypotenuse over adjacent. So that means this is x squared minus 4. So really the only thing that changes is that this is x squared and this is 4. Okay, not too bad. I probably give myself like one piece off and then count everything else is correct. Okay. I am missing the other 10 problems, but you know what? Maybe that's a good thing. So that way I can split this video into parts in case I have to print it. I don't want to worry about printing it. So, yeah, this was accidentally part 1. You should see part 2 in just a bit. See you in a moment.